Same objective, just a little bit different equations. Still going to solve equations with logs. Here's the first one. You have 10 to the negative 2x minus 3 power equals 4 to the negative 3x plus 5 power. You don't have a base of e in either one of these, so a common log will do. And you can take the log of both sides by doing this. Log of 10 to the negative 2x minus 3 power equals log of 4 to the negative 3x plus 5 power. Move your exponents out in front of the logs to get a negative 2x minus 3. That's a quantity times log 10. And then on the other side, quantity of negative 3x plus 5, close the quantity, times log 4. You're going to have to distribute the log 10 through the parentheses. So you should have a negative 2x log 10 minus 3 log 10. Then on the right side, distribute the log 4 to get negative 3x log 4 plus 5 log 4. You have to solve for x, but you have x on either side. This is no different than 2x plus 3 equals x minus 7. It's that simple to solve. It just doesn't look like it. You have an x term on the right hand side. You have to move it over to the left. And then you have a constant term here. You move it over to the right. So you're going to keep the negative 2x log 10 where it's at, and this one is going to go over and become plus 3x log 4. On the right side, 5 log 4 will stay there, but that constant from the left will go over and become plus 3 log 10. So you have x's on the left, constants on the right, but all we need is an x. Just to get an x out of the left side, you just factor it out. Factoring out an x, so it should be x times the quantity negative 2 log 10 plus 3 log 4. Notice the x has been taken out of each of these and just placed outside the parentheses. If you distribute this through, you get right back to where you were there. And on the right side, it just stays the way it is. 5 log 4 plus 3 log 10. And to solve for x, you would have to divide the right-hand side, 5 log 4 plus 3 log 10, by what is attached to the x, which is negative 2 log 10 plus 3 log 4. Take great care in your calculator to type this in properly. Put parentheses here, here, and on the bottom around all of it, and then there and there. So on the top we have 5 log 4 plus 3 log 10. And we're going to divide that by negative 2 log 10 plus 3 log 4. Anybody get an answer yet to the fourth decimal place? What'd you get? Well, give it a try.
Is it like negative 12.467?
Might be. Did anybody get something that starts with a 12? Did anybody get something that starts with a negative 31? Yeah. So negative 31.0009, and then that would be 7 at the very end. Rounding to the fourth decimal place. There's no base of e, so there's no need to use a log natural, so you can use the common log for this one. So you need a log of 6 to the 3x plus 4 power equals log of 2 to the 2x plus 8 power. And remember your property of logarithms, you can move the exponent down to the left. Quantity of 3x plus 4, close quantity times log 6 equals quantity of 2x plus 8, close the quantity, log 2. Distribute your logs through the parentheses on both sides. So you should have 3x log 6. There's no need for a parenthesis in there. Right there. So that's not a 13, that's just me scratching something out. And then plus 4 log 6. On the right side, 2x log 2 plus 8 log 2. X's on the left hand side. So you're going to keep the 3x log 6 and move this one over with it, minus 2x log 2. On the right side, keep the 8 log 2 and move this one over. Make it minus 4 log 6. X's are on the left hand side. You have to factor out an x from each term to be left with 3 log 6 minus 2 log 2. Right hand side stays the same on this step. And your last thing to do to solve is to divide the right hand side by what's attached to the x on the left. So 3 log 6 minus 2 log 2. Use your parentheses like we went over in the last problem. 8 log 2 minus 4 log 6. And then divide by 3 log 6 minus 2 log 2. And round to the nearest, let's see, round to 4 decimal places. Anybody get a number?
Is it 0.6115?
Did anybody else get something that starts with 0.6?
No, negative 0.4066.
That's right. Should be negative 0.4066. You should have a log of both sides. Log of 12 to the x plus 2 equals log of 3 to the 2x minus 1. Put the exponents down to the left like this, and also on the quantity of 2x minus 1, and then log 3. There we go. Okay, so to distribute the log 12 to come up with x log 12 plus 2 log 12. And then distribute the log 3 to get 2x log 3 minus log 3. You have to have your x's on the left-hand side. So it's going to be x log 12 and then minus 2x log 3. And on the right, negative log 3 minus 2 log 12. Factor out an x on the left. X times the quantity, log 12 minus 2 log 3. And then on the right hand side, it's going to stay the same. Alright, to get your answer, you're going to have to do the right hand side divided by what is attached to the x on the left. Okay, so let's type this in. The whole top should be in a quantity by itself. So the quantity of negative log 3 minus 2 log 12. And then we'll divide by log 12 minus 2 log 3. Answer should be a negative 21.0942. Alright, for this, you should have log of 7 to the negative 3x minus 4 power equals log of 6 to the 4x plus 5 power. Move your exponents out to the left of the logs to get the quantity of negative 3x minus 4. Close the quantity. Log 7 equals quantity of 4x plus 5. Close the quantity. Log 6. So distribute the log 7 to get 3x log 7 minus 4 log 7. And set that equal to 4x log 6 plus 5 log 6. You'll have to rearrange your items so that the x's are on the left. So keep this one where it's at, but move that one over. And I did not put a log beside that. That should be, or the log of 6 I should say, but there it is, and minus 4x log 6. On the right, 5 log 6. Move this over and make it plus 4 log 7. So factor out an x to get negative 3 log 7 minus 4 log 6. And on the right, this will simply stay the same. Alright, so now we have to divide. We are dividing 5 log 6 plus 4 log 7 by negative 3 log 7 minus 4 log 6. Okay, in the calculator, let's see how this works out. It's going to be 5 log 6 plus 4 log 7, and then divide by negative 3 log 7 minus 4 log 6. Okay, did anybody come up with negative 1.2874?